होगा बेटा,
ठीक है सर।
क्लास के आखिर में होगा। A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. In the last class, we were talking about the causes of inadequate durability. So today we will be talking about the de-icing effects, which is another cause of inadequate durability to the concrete. So according to the National Ready-Mix Concrete Association, de-icing chemicals are used for snow clearance. When there are more snowfall in cold winter in such areas, just like in Europe or in USA, then they are clearing the roads from this snow by using some salts or some chemicals. So by using these salts or chemicals, they can affect the concrete both physically and chemically. Physically, they can damage their surfaces, and chemically, they can cause corrosion of the reinforcement. If you people have steel bars in the concrete, or they can cause sulfate attacks or some other chloride attacks in the concrete. The physical effects are typically manifested as cracking and salt scaling. This physical effects are, as I told you, it can cause cracks of the concrete or scaling of the surfaces of the concrete. Its surfaces damage or it's got cracks, just like when you remove the surface of something and it is exposed. So the same process is taking place when you are removing these snow from the roads with the help of salts or chemicals. So they are causing scaling, that is the removal of the surface or damage of the surface. Scaling is the flaking or peeling of a finished concrete surface, and is typically a result of the presence of moisture and de-icing salt on concrete during freeze and thaw action. So this when जब हम स्नो रिमूव करते हैं इन रोड से विद द हेल्प ऑफ साल्ट्स और केमिकल्स, तो इसका जो सरफेस है ये खराब हो जाता है। इसका जो छिलका है सरफेस का, इसका जो टॉप लेयर है वो खराब हो जाता है, वो खत्म हो जाता है, जिसकी वजह से आपकी जो कंक्रीट है वो उसके सरफेस में क्रैकिंग आ जाती है। और ये क्यों होता है? दिस इज बिकॉज ऑफ दिस आइसिंग साल्ट्स, और हमने पढ़ा हुआ है कि इसमें फ्रीज एंड था एक्शन भी होगा, तो उसकी वजह से भी इसमें क्रैकिंग आएंगी। The chemical effects can result from reactions involving cement hydration products. Chemical reaction में आप हमें पता है कि chemical hydration process से गुजरता है। hydration products में aggregates और reinforcing steel bars, इनके दरमियान फिर जो bonding है या जो इनके दरमियान जो bond बना होता है उसमें de-bonding आ जाती है। The reactions caused by de-icer ions include the leaching of calcium hydroxide from the paste, the decalcification of calcium silicate hydrate, the conversion of calcium silicate hydrate to magnesium silicate hydrate. इस रिएक्शन में कौन कौन से प्रोसेस इन्वॉल्व होते हैं कि इसमें कैल्शियम सिलिकेट हाइड्रेट आपका बन जाता है, फिर वो कन्वर्ट हो जाता है टू मैग्नीशियम सिलिकेट हाइड्रेट, एंड द फॉर्मेशन ऑफ ब्रोसाइड, कॉम्प्लेक्स साल्ट्स एंड ऑक्सीक्लोराइड, ये सारी चीजें बन जाती है, जिसकी वजह से आपका जो कंक्रीट है और जो कंक्रीट सरफेस है वो खराब हो जाता है। According to the National Ready-Mix Concrete Association, most scaling is caused by, ये जो स्केलिंग है जो सरफेस का खराब होना है ये किसकी वजह से होता है? नंबर 1, this is because of the excessive application of calcium or sodium chloride de-icing salt. जब आप सोडियम क्लोराइड या कैल्शियम क्लोराइड साल्ट यूज करते हैं तो उसकी वजह से एक्सेसिव अमाउंट आप यूज करते हैं तो इसकी वजह से जो सरफेस है ये खराब हो जाता है। Especially if concrete does not have adequate air entrainment or has not been properly covered. खासतौर पर कहाँ पे ज्यादा रोड खराब होता है, कहाँ पे ज्यादा कंक्रीट खराब होता है? जहाँ पे आपने ईयर एंड मिक्सचर यूज नहीं किया होता है या आपने उसकी प्रॉपर केवरिंग नहीं की होती है। इनसफिशिएंट केवरिंग व्हिच लीड्स टू अ वीक सरफेस स्किन। अगर आपने प्रॉपर केवरिंग नहीं की हो, आपने कंक्रीट को प्रॉपर कवर नहीं किया हो इसकी फिनिशिंग के बाद, तो इसका जो सरफेस है, इसका जो स्किन है वो कमजोर हो जाता है और बहुत आसानी से खराब हो जाता है। द यूज, शहजाद कैन यू हियर मी बेटा?
Yes, sir, I can hear you properly.
The use of non-ear entrained concrete. Okay, अगर आपने ear entrained मिक्सचर यूज नहीं किया है तो फिर क्या नुकसान होगा कि जो आपके पास जो स्ट्रेसेस डेवलप होते हैं कंक्रीट में ड्यू टू द एक्स्ट्रा वॉल्यूम ऑफ वाटर इन द फॉर्म ऑफ आइस, तो उसकी वजह से भी आपकी कंक्रीट में क्रैक्स आ जाती है और खराब हो जाती है। ब्लीड वाटर दैट्स बीन वर्क बैक इनटू द सरफेस causing a higher water to cement ratio। ब्लीडिंग वाटर जब सरफेस पे आ जाती है और उसकी आप फिनिशिंग करते हैं, वो जो सरफेस पे कुछ टाइम के लिए रह जाती है एंड यू आर ट्राइंग टू यूटिलाइज देम बैक इन द कंक्रीट, और उसमें जो 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 पाथ्स बन जाते हैं, जिन पाथ्स के थ्रू ये ब्लीडिंग वाटर सरफेस पे आ जाती है, तो दीज पाथ्स which have been made by these water when they were traveling to these surfaces, वही वायर्स उस कंक्रीट में रह जाते हैं ड्यू टू द हाई वाटर सीमेंट रेशो एंड ड्यू टू दीज वायर्स आर पोर्स। आपका जो कंक्रीट है वो पोर्स होता है और उसमें उसकी जो स्ट्रेंथ है वो कम पड़ जाती है। हाउ टू प्रिवेंट कंक्रीट स्केलिंग, आप कंक्रीट के सरफेस को कैसे बचा सकते हैं, कैसे महफूज रख सकते हैं। नंबर 1, डू प्रैक्टिस प्रॉपर केवरिंग प्रैक्टिसेस। क्या करें कि आप प्रॉपर केवरिंग करें, प्रॉपर केवरिंग प्रोवाइड करें कंक्रीट को। दिस इंश्योर्स द प्रॉपर रिएक्शन ऑफ सीमेंट विद वाटर, इससे आपकी जो हाइड्रेशन रिएक्शन है उसको आप हेल्प करते हैं देयर बाय क्रिएटिंग अ स्ट्रॉन्गर सरफेस। तो इसकी वजह से आपका जो कंक्रीट है वो स्ट्रांग हो जाता है, मजबूत बन जाता है और उसकी जो स्केलिंग है वो कम हो जाती है। Do allow adequate air entrainment. Always try to use air entrained admixtures in such cases. Do protect newly placed concrete from harsh winter weather and freezing temperature with concrete sealers or concrete blankets. You can use some covering just like plastic sheets or some other sheets just like tarpaulin and some other materials which we will discuss in our today lecture in the cold weather concreting. Or you can use the concrete blankets so that you can cover the concrete surface and you can keep it safe from the present actions. Don't overwork the concrete surface during finishing. When you are doing finishing of the concrete, तो उस पे बहुत ज़्यादा उस पे overwork न करें, just required finishing करें और उस पे फिर मजीद उसको हर वक्त मेसन्स क्या करते हैं, लेबर्स क्या करते हैं, उसको बार बार फिनिशिंग करते हैं, उसके सरफेस पे बार बार आके उसकी फिनिशिंग करते हैं, उस पे काम करते हैं। So overworking can reduce the air content, leaving the concrete slab susceptible to scaling when temperature drop below freezing। यहाँ पे क्या होता है कि जब आप बार बार उस पर काम करते हैं, उसकी ओवर कंपेक्शन करते हैं, उस पर ओवर वर्किंग करते हैं, तो यहाँ पे जो एयर कंटेंट होता है वो खत्म हो जाता है। और जब एयर कंटेंट आप खत्म करते हैं तो वहाँ पे फिर आप स्केलिंग के चांसेस बढ़ जाते हैं और जब टेम्परेचर आपका फ्रीजिंग से कम हो जाता है तो फिर ये फ्रीज एंड था एक्शन की वजह से, जो फ्रीज एंड था साइकिल्स होते हैं उसकी वजह से भी आपका कंक्रीट खराब हो जाता है। Here you can see ये surfaces, these surfaces has been damaged because of this scaling or these this attacks, this chemicals attacks or this present action. Don't use de-icing salts. De-icing salts इस्तेमाल न करें, such as calcium or sodium chloride. कब इस्तेमाल न करें बेटा? Within the first year of freshly placed concrete. अगर आप पहले साल में आपने कंक्रीट प्लेस किया हो तो we know that it is getting strength throughout the year, तो पहले साल में आप लोग ये de-icing salt इस्तेमाल न करें। Okay, if you are not using these salts as de-icing salts, तो फिर क्या इस्तेमाल करें? Instead of these salts, use sand to increase the traction। क्या करें? सैंड इस्तेमाल करें, इससे जो फ्रिक्शन है रोड सरफेस के दरमियान और जो बॉडी या टायर या व्हीकल इससे पास होते हैं उसके दरमियान फ्रिक्शन बढ़ जाता है। एंड हुज अप सर्फेसेस टू रिमूव द सॉल्ट डिपॉजिट्स लेफ्ट बिहाइंड बाय कार्स, और आपका जो सरफेस है वो साफ करता है। जो साल्ट वगैरह आप जब गाड़ियाँ गुजर जाती है उस और कोई साल्ट वगैरह अगर रह भी गया हो इस सरफेस पे तो उसको साफ करती है। तो आप क्या करें कि आप रेत इस्तेमाल करें आप पहले साल में इंस्टेड ऑफ यूजिंग दिस कैल्शियम और सोडियम क्लोराइड in order to avoid these scalings or damaging of the surfaces of the concrete. Don't use ammonium sulfate or ammonium nitrates as de-icers. Ammonium sulfate or ammonium nitrate बिल्कुल इस्तेमाल न करें because these are aggressive chemicals and this will destroy the concrete surfaces. These are very aggressive chemicals and this will destroy, ये तबाह कर लेगी, ये खराब कर लेगी आपको जो कंक्रीट का सरफेस है वो बहुत ज़्यादा ख़राब कर लिए। तो आप कोशिश करें कि ये दो साल्ट्स बिल्कुल इस्तेमाल न करें। The next topic of the inadequate durability is the thermal stresses. So let me ask someone about the thermal stresses, that what will happen due to these thermal stresses. Muhammad Yasser Sami. Muhammad Yasir Sami.
Yes, sir.
थर्मल स्ट्रेसेस क्या होते हैं बेटा? वकास अहमद, वकास अहमद, वकास बेटा, अरेब जहांगीर।
यस सर। सर टेम्परेचर के इंक्रीज के साथ एक्सपेंशन होती है और एक्सपेंशन की वजह से जो एक स्ट्रेस सा पैदा होता है, मतलब उसको कहते हैं थर्मल स्ट्रेस।
ठीक है, तो कंक्रीट में एक्सपेंशन होगी या कंट्रैक्शन होगी टाइम के
सर
साथ?
इंक्रीज इन टेम्परेचर के साथ तो एक्सपेंशन होगी।
कंक्रीट में एक्सपेंशन होगी। आर यू श्योर?
सर इंक्रीज इन टेम्परेचर के साथ तो होगी। यस।
ओके, शहजाद।
Yes, sir.
शहजाद बेटा, कैन यू हेल्प अस? टेम्परेचर
Sir,
इंक्रीज के साथ या कंक्रीट का एक्सपेंशन होगा या कंट्रैक्शन होगा?
सर टेम्परेचर इंक्रीज के साथ कंप्रेशन होगा सर, कंप्रेशन, और टेम्परेचर डिक्रीज के साथ एक्सपेंशन होगा।
क्या मसला होगा?
सर टेम्परेचर डिक्रीज के साथ एक्सपेंशन होता है सर, और टेम्परेचर इंक्रीज के साथ कंप्रेशन होता है।
मतलब उसका जो वॉल्यूम है वो कम होगा, कंट्रैक्शन होगा।
सर जब टेम्परेचर डिक्रीज होता है तो उसका वॉल्यूम इंक्रीज होता है सर, एक्सपेंशन होता है।
ये किसने कहा है?
सर
जी
सर
जी बेटा।
सर सही है सर। सर टेम्परेचर इंक्रीज के साथ सर एक्सपेंशन होती है सर, मॉलिक्यूल एक्साइट होते हैं सर, एक्सपेंशन होती है। इंक्रीज इन टेम्परेचर कॉजेज एक्सपेंशन, वेयर एज डिक्रीज इन टेम्परेचर कॉजेज कंप्रेशन।
सर डिक्रीज इन टेम्परेचर कॉजेज कंट्रैक्शन, उसमें पानी निकल जाता है और डिहाइड्रेशन हो जाती है। और जब
आप लोगों ने हाइड्रोजन पढ़ा हुआ है, आप लोगों ने ऑटोजीनियस श्रिंकेज पढ़ा हुआ है। तो कंक्रीट में नॉर्मली श्रिंकेज होता है, तो डोंट यूज कहाँ पे थे, यहाँ पे। Stresses caused due to the change in temperature are called thermal stresses. The stresses which are caused due to the change in temperature or due to the high temperature, these are called thermal stresses. A change in temperature causes material to deform. When there is any change in the temperature, it will cause the deformation of the material, either in the form of expansion or either in the form of contraction. If these deformations are restricted, anyhow, what are we doing? We are trying to restrict these deformations in the form of concrete. How we can restrict them? We are using steel bars in the concrete. We are using reinforced concrete in most of the structure. So when we are using reinforced concrete, we are restricting these deformations. We are restricting these contractions in the concrete. It would result in generation of stresses. Thermal stresses may cause material to crack. So there are the chances of cracking of the concrete due to these thermal stresses. So maybe you have seen when these spaces or these giants, so the engineers or the workers or the designers, they are providing space for this expansion. When there is expansion in these materials from either sides, so they can accommodate in this space. But if you are not providing these spaces and it is getting expansion, what will happen? It will cause damages of the material. So material undergo thermal expansion or contraction when exposed to temperature changes. So when it is in the form of steel, it will expand, but when it is in the form of concrete, so concrete normally shrink. Railroads, tracks, and bridges. Maybe you people have seen the railroads, which are the rail tracks, which are made from the steels, and the bridges. for example, have expansion joints. They are normally having expansion joints to allow them to freely expand and contract with the temperature changes. So in winter, they are trying to contract the steel bars, and in summer, they are trying to expand. So when they are expanding, they are trying to accommodate in the expansion joints. So it will not cause damages of the tray. Okay. Now the next topic is hard weather concreting. We have already discussed many times that in hard weather concreting we are trying to use retarders, and in cold weather concreting we are trying to use accelerators. So today we will be talking about these hard weather concreting and cold weather concreting in detail. So let's talk about the hard weather concreting. The hard weather concreting is defined by American Concrete Institute as one or a combination of the following conditions, these conditions which we will discuss in detail. One or a combination of the following conditions that tends to impair the quality. These factors are trying to impair or to damage the quality of the freshly mixed or hardened concrete by accelerating the rate of moisture loss and rate of cement hydration. What these factors are doing, they are trying to accelerate the rate of moisture loss, and also it is trying to accelerate the cement hydration reaction, or otherwise causing detrimental results or causing damages in the concrete or causing weakness of the concrete. So what are these factors? Number one is the high ambient temperature. The high ambient temperature, the high concrete temperature. The high ambient temperature means the temperature of the surrounding or the atmospheric temperature. The high concrete temperature, the temperature of the concrete by itself. The low relative humidity. The low relative humidity, if there is low humidity in the atmosphere, and the high wind speed, the wind is blowing with very high speed. So how it will affect the concrete strength, the concrete hydration reaction, and all other properties of the concrete. So according to this definition, एक फैक्टर और या इसमें से दो फैक्टर्स या ये सारे फैक्टर्स अगर मौजूद हो तो that is called hard weather or hard weather concreting. अगर ये सारे फैक्टर्स मौजूद हो या इसमें से एक या दो मौजूद हो और इस कंडीशन में आप कंक्रीटिंग करते हैं, so this concreting is known as hard weather concreting. High ambient temperature, atmospheric का टेम्परेचर बहुत ज्यादा हो, just like nowadays, कंक्रीट का टेम्परेचर बहुत ज्यादा हो, इसमें जो मटेरियल आपने यूज किया उसके साथ आपने कोई ट्रीटमेंट न की हो, हवा में नमी कम हो, और हवा का जो स्पीड है, जो हवा चलती हो जिन जगहों पे उसका स्पीड बहुत ज्यादा हो, because it will help the evaporation. So let's talk about these things one by one. Difficulties caused by hard weather concreting. When you are placing concrete in hard weather, what are the difficulties which you have to face and which you have to handle on site? Increased water demand. When you are working in hard weather, the demand of the water in the concrete increases. The accelerated slump loss leading to the addition of water on job site. When the water demand increases, because the evaporation will take place, the accelerated slump loss, it will cause the loss in slump leading to the addition of water on job site. So maybe you have heard the people when they are calling, yaar pani dal do, alako bore ke vacho, pani dal do. Because of the hot weather, most of the water that is trying to evaporate, and the workability of the concrete is becoming less. So they are trying to increase the workability by the addition of water. But what they do, they are damaging the other properties of the concrete by adding only water. Increased rate of setting resulting in placing and finishing difficulties. Because of the high temperature, the hydration reaction is very high, so the rate of setting is decreasing, and also the setting time is decreasing. So it is difficult for the masons or for the workers to finish this concrete properly. Increased tendency of our plastic shrinkage or shrinkage cracking. So when this concrete is becoming hard in very less time, so there are chances of plastic shrinkage. We have already discussed this plastic shrinkage. Critical need for prompt early curing. When you are working in hard weather, you have to, once you have finished the finishing of the concrete surfaces, then you have to provide the curing as early as possible. Difficulties in controlling entrained air. It is very difficult for the masons or laborers so that they can control the entrained air inside this concrete. Decrease the strength resulting from high water demand. As I told you, the water demand increasing, the people are adding water and they are not adding cement, they are only adding water. So if you are only adding water, you are increasing the workability bar, but on the other side you are decreasing the strength of the concrete. Increase potential for thermal cracking. Yes, when there is early drying of the concrete, there are maximum chances of thermal cracking because of the high temperature. Decreased durability due to cracking. Due to this cracking, the durability of the concrete decreases. Due to this shrinkage of the concrete, the durability of the concrete decreases. Increased permeability. As the people or the masons or the laborers are adding, or the workers are adding water, so they are actually increasing the permeability of the concrete. They are not making this concrete impermeable because this water cement ratio is increasing. Non-uniform surface appearance. If you are doing these processes, if you are working in hot weather, so you may not be able to finish all the surface uniformly. So you will see non-uniform surfaces in this concrete. Increased tendency for drying shrinkage. As I told you, if you are working in hot weather, so the probability of dry shrinkage increases due to this high temperature. Shazal beta, can you hear me?
Yes, sir, I can hear you properly.
Okay, beta. As concrete temperature increases, there is a loss in slump that is often unadvisedly compensated for by adding water to the concrete at the job site. As we discussed that there will be loss in slump as the temperature increases, there will be the loss in slump. And if there is in the loss in slump, the workability of the concrete will decrease. So what the masons or the workers are doing, they are trying to increase the workability of this concrete, and they are trying to compensate this loss in slump by adding water on job site. At higher temperature, a greater amount of water is required to hold the slump constant than is needed at lower temperature. Yes, at high temperature, because of the water evaporation from the concrete, there will be, if you want to keep the slump constant, you will need more water as compared to low temperature. If you are working in low temperature or in low temperature weather, then there will be no loss in the slumps and you will need no water. Adding water without adding cement results in a higher water cement ratio. As I told you, if you are adding only water and you are not adding cements with this, so you are increasing the water cement ratio, thereby lowering the strength. So you are decreasing the strength of the concrete at all edges and adversely affecting other desirable properties of the hardened concrete, just like the toughness, the density of the concrete, the hardness of the concrete, and durability of the concrete, and impermeability of the concrete. All these qualities or all these properties or all these characteristics of the concrete will be affected. Adding cement to compensate for the use of additional mixed water may not be enough to achieve the desired concrete properties, because additional cement will further increase the concrete temperature and water demand. Okay, if you are adding cement along with this water, so this will be not the only solution, because when you are adding more cement, you are also increasing the hydration reaction, because the rate of the hydration reaction, because if you are adding more cement, you are increasing the rate of hydration of cement, so there will be more heat will be generated. So we should try in such a way that we can lower the heat generation, we can control the hydration reaction, we can control the setting time. So we will discuss how we can do this. Now let's discuss the relationship between temperature, slump, and air content. So here you can see on the x-axis the concrete temperature in degree centigrade. Here you can see on the top the concrete temperature in degree Fahrenheit. On the y-axis you can see the air content in percentage, and here you can see this line shows this 1 inch slump, this line shows 3 inch slump, this line shows 5 inch slump, and this line shows 7 inch slump. So you can see if the temperature is just like 10 degrees C. So here you can see the air content required or the percentage of air content is less. But when you come to this 35 degrees C, so it is further decreasing. It is further decreasing. When you are coming to 3-inch slump, so you can see this, the air content percent has increased, but at higher temperature it has decreased. So at higher temperature, the air content or the percentage of air content, it is increasing. It is increasing. But when you come to the lower temperature sides, it is decreasing or it is normal. Effects of high concrete temperature, you can see in this graph. On the x-axis we have concrete temperature in degree centigrade and concrete temperature in degree Fahrenheit. Here you can see the water content in kilogram per cubic meter, and here you can see the water content in pounds per cubic yard. So here you can see this line, this is directly proportional. This is a linear relationship. So as the temperature increases, the water content or the demand of the water increases. As the temperature decreases, the demand of water also decreases. So in the hot weather, water is the main factor that its demand increasing. What are the effects of high temperature on the concrete? So this plot shows this one, the effect of high initial concrete temperature on compressive strength. Here you can see the age of test days on which you have tested the concrete cylinders. This is the 3 days, this is the 7 days, and this is the 28 days. On the y-axis you can see the compressive strength, and this is the percent of 28 days strength of the concrete. So on the 28 days, if you look over here, if you have 49 degrees, if you are working, if you are placing the concrete and 49 degrees C temperature, you can see its 28 days strength is less than almost 70%. But if you are working in 32 degrees C temperature, which is less than this 41 degrees C temperature, which is less than 49 degrees C, so its strength increases almost 82 or 83%, up to 82 or 83% of the 28 days strength. So again, this is, we are checking this on 28 days. So here you can see at 32 degrees C, it is almost 100%. It is almost 100%. So this temperature is a major factor which affect the strength gaining of the concrete. The strength gaining of the concrete. And if you look over here at 365 days, this high temperature, which was initially very high temperature, its strength is less as compared to the 32 degrees C temperature. Early strength up to 4 to 5 days is better at higher temperature, but lower at 28 days and beyond. If you look over here, the early strength of this 49 degrees C is higher than the other strength. This instead of this one here, you can see this is the line, this is the 49 degrees C temperature. So its strength is on higher side as compared to this one. Shahzad?
Yes, sir.
Is it okay?
Yes, sir. It is okay.
Okay, so what are the precautions? How we can handle or how we can make the concrete properly in hot weather, so that we can have its good strength and also its good property, that is durability, toughness, hardness, impermeability, etc. Number one, what you can do, आप क्या कर सकते हैं? Begin the concrete placement at the coolest time possible. दिन या रात के वक्त में ऐसे टाइम पे आप कंक्रीट शुरू करें जब टेम्परेचर कम से कम हो. If your बेज प्लांट cannot deliver at night, जहां से आप कंक्रीट आपको मिलता है, प्लांट से जहां से आप कंक्रीट ले आते हैं, अगर if they cannot work during night, if they have some problem, they are not working at night time, फिर क्या करें? Try to schedule your concreting or pour the concreting as early in the morning as possible. सुबह के वक्त भी टेम्परेचर कम होता है, तो आप लोग कोशिश करें कि सुबह के अर्ली इन द मॉर्निंग आप लोग कंक्रीटिंग करें, इससे आपकी जो हार्ट वेदर इफेक्ट है वो कम से कम होगा. Use a retarder and water reducing additives or admixtures to slow the setting so that the concrete crew will have time to finish the concrete correctly. आप retarder admixture use करें, retarding admixture use करें so that you can increase the setting time of the concrete. Or water reducing admixture use करें, just like plasticizers or super plasticizers. This will increase the setting time of the concrete, and the people who are working on the concrete or placing the concrete or finishing the concrete, they will get enough time to perform all these works or all these activities. Use a low heat design mix. क्या करें? ऐसा सीमेंट इस्तेमाल करें जिसमें हीट जनरेशन बहुत कम से कम हो, हाइड्रेशन रिएक्शन में उसकी जो हीट इवॉल्व हो रही है वो कम से कम हो. Portland cement is not all the same. There are low heat mixes or blends that are ground differently and different formulations to reduce the heat of hydration. आप क्या करें कि पोर्टलैंड सीमेंट का वो टाइप इस्तेमाल करें जिसमें हीट कम से कम इवॉल्व हो रही, लो हीट सीमेंट आप यूज करें, so it will also help you in controlling this hard weather, in controlling the cracks or damages in the concrete due to this hard weather. Moisten the subgrade, the steel reinforcement and form work prior to concrete placement. This is one of the best procedure. आप क्या करें, जहाँ पे आप कंक्रीट इस्तेमाल करते हैं, जहाँ पे जो जमीन का जो सतह है, सरफेस है, उसको आप उस पे आप पानी स्प्रे करें, उसको गीला करें. जो स्टील रिइंफोर्समेंट आप इस्तेमाल कर रहे हैं उसको भी गीला करें, और जो फॉर्म वर्क आप इस्तेमाल करें उसको भी पानी स्प्रे करें ताकि उसका टेम्परेचर कम से कम हो जाए. Erect the temporary vents bricks to limit the wind velocities and sun shades to reduce concrete surface temperature. आप क्या करें, हवा के रूख को, हवा के जो स्पीड है उसको स्टॉप करने के लिए, उसको कम करने के लिए आप बैरियर्स प्रोवाइड करें. आप जिस एरिया में कंक्रीटिंग करते हैं उसको कवर करें. और सन शेड्स और सन को कवर करने के लिए क्या करें कि आप ऊपर से साए के लिए कुछ उस पर कोई प्लास्टिक या तरपाल या कोई कवर उस पर डाल दे, बल्कि कोई साए सा बना ले, कोई शेड सा बना ले, ताकि आप टेम्परेचर या जो सन का जो डायरेक्ट जो इफेक्ट है उसको कम से कम कर सके. नेक्स्ट क्या कर सकते हैं आप, रिड्यूस द सीमेंट कंटेंट ऑफ द डिजाइन मिक्स. कोशिश करें कि आप जो सीमेंट कंटेंट है उसको कम से कम करें if possible or when possible. Using fly ash at a higher than ordinary proportion. As we have discussed this mineral admixtures, you can replace this up to 30%. तो कोशिश करें कि जितना मैक्सिमम आप इसको रिप्लेस कर सकते हैं with the cement, do that. Will lower the heat of hydration, and if other adjustments are made to the design mix, your concrete will have the same compressive strength. Okay, so the design strength of the concrete will not be affected. Next one, cool the aggregates. Aggregates को भी आप ठंडा करें. कैसे करेंगे? Either by installing water sprinklers, उस पे पानी स्प्रे करें, और storing in a shaded location, या साए में आप उसको स्टोर करें where possible. Concrete temperature is reduced by 1 degree C temperature. जो कंक्रीटिंग आप करते हैं उसका टेम्परेचर 1 डिग्री सी कम हो जाते हैं. कैसे कम हो जाते हैं? If you are trying to decrease the temperature of the water by 4 डिग्री सी, अगर आप वाटर जो यूज करते हैं आप कंक्रीट में, उसकी टेम्परेचर अगर आप 4 डिग्री सी डिक्रीज करते हैं तो आपका टेम्परेचर, कंक्रीट का टेम्परेचर 1 डिग्री सी कम हो जाता है. और अगर आप 2 डिग्री टेम्परेचर ड्रॉप करते हैं आपको जो एग्रीगेट्स का, तो उससे भी आपकी कंक्रीट का टेम्परेचर 1 डिग्री सी टेम्परेचर कम हो जाता है. So you can reduce the temperature, or you can spray water on the aggregate so that you can reduce or you can drop its temperature. You can use ice in the water. You can use chilled water. Use ice instead of water in the mix, or use chilled water to reduce the initial mixing temperature. ठीक है, आप क्या कर सकते हैं, आप आइस यूज कर सकते हैं, आप ठंडा पानी इस्तेमाल कर सकते हैं ताकि आप कंक्रीट का जो टेम्परेचर है उसको कम से कम कर सकें. Be prepared. आप तैयार रहे to begin the curing immediately after the concrete is finished. As soon as possible, or as soon as you have finished or completed the finishing of the concrete, you have to just start. You have to immediately start the curing of this concrete. Whether you use a fluid applied curing compound, either you can use the curing compound. Nowadays they are available from different companies. So if you use that curing compound, then there is no need of curing. With curing, you can provide some bags on the top surfaces. You can provide some sheets or a plastic sheeting. The chosen method should be incorporated as early as possible. Whatever method you are adopting, but this should be adopted as early as possible. Fogging cools the air and raises the relative humidity above plate work. Fogging, with the help of fogging, what you can do, you can cool down the air and you can raise the relative humidity above the surface of the concrete to lessen the rapid evaporation from the concrete surface. With the help of this, you can stop or you can decrease the evaporation from the concrete surface. You can see over here, thus reducing the cracking and improving the surface durability. You can use here. This is the fogging. Liquid nitrogen are added directly into a truck mixer. What you can do, the next step, you can add the liquid nitrogen to the concrete in the truck mixers at the ready mix plant as an effective method of reducing the concrete temperature for mass concrete placements or during hot weather concreting. So all these are the precautions, or all these are the procedures which you people can adopt during hot weather concreting. Now there are some thumb rules which people are using in the field. For every 10 degree Fahrenheit increase in the concrete temperature, how much water you need? You need 1 gallon extra water or 1 cubic yard of concrete to maintain a given slump. You lose about 1 hour of sitting time if you are working in hot weather concreting and the temperature rises by 10 degree Fahrenheit. So if you have the sitting time is 90 minutes, so 60 minutes is gone. If you add that 1 gallon of water, if you add this extra 1 gallon of water to the concrete, what will happen? You will lose 150 pounds per square inch of the compressive strength of the concrete. आपका जो strength है concrete का वो कम हो जाता है. Now coming towards the cold weather concreting. शहजाद, cold weather concreting में क्या होगा? We have discussed the hot
सर
weather
ये वो कंक्रीटिंग होती है जो हम कोल्ड वेदर में करते हैं सर. इसमें हाइड्रेशन रेट जो होती है सर वो कम होता है सर. हम एक्सीलरेटर्स डालते हैं ताकि हाइड्रेशन रिएक्शन इंक्रीज कर सके.
We have discussed that in hard weather there will be the chances of shrinkage cracking or the cracks in the concrete or the damages of the concrete because of this high evaporation, loss of slump, more water content in the concrete, and you need early curing of the concrete. So let me ask someone else. Ahmad Khan, are you in the class? Ahmad Khan, beta. Ahmad.
Yes, sir.
Ahmad. You are in the class, beta. Can you help us?
Yes, sir.
Ji.
Like how?
Can you comment on this?
Yes, sir.
जैसे मैंने बता दिया कि हार्ड वेदर कंक्रीटिंग में हमारे पास ये मसाइल होते हैं और ये क्रैक्स इस वजह से प्रोड्यूस होते हैं. तो कोल्ड वेदर कंक्रीटिंग में आया क्रैक्स आएंगे कि नहीं आएंगे? अगर आएंगे तो कैसे होंगे और क्रैकिंग किस वजह से होगी? जी बेटा, बता सकते हैं बेटा?
उसकी पॉसिबिलिटी कम होगी क्रैक्स आने की.
जी बेटा, शाबाश.
इसमें कब होगी?
ओके, अलीना दाऊद.
Yes, sir.
बेटा, कैन यू हेल्प अस?
Yes, sir. Sir,
कोल्ड वेदर कंक्रीटिंग में क्या होगा?
Sir, cold weather
जी
concreting
बेटा.
में हाइड्रेशन रिएक्शन डिले हो जाएगा ना, तो
ठीक है.
सर कोल्ड वेदर कंक्रीटिंग में हाइड्रेशन रिएक्शन स्लो हो जाएगा, तो फिर ब्लीडिंग के चांसेस ज्यादा होंगे क्योंकि वाटर इवेपोरेट नहीं होगा.
शाबाश, गुड. दिस इज अ गुड पॉइंट. इसके अलावा Uh, Shahidullah,
Yes, sir.
can you help us?
Yes, sir. जो कोल्ड कंडीशन होता है उसमें जो है ना जो वाटर हमने ऐड किया होता है ना कंक्रीट में, तो उसमें उसके आइस बनना शुरू हो जाता है, मतलब वो आइस में कन्वर्ट होना शुरू हो जाता है, जिसकी वजह से जो है ना उसमें वॉल्यूम जो है ना वो इंक्रीज हो जाता है और उसकी वजह से क्रैक्स आ जाते हैं। तो फिर हम उसमें एयर इंट्रेंट जो एडमिक्सचर है वो हम यूज़ करते हैं, ताकि वो जो वॉल्यूम इंक्रीज होता है वो उस जो बबल्स होते हैं ना उसमें जो एयर इंट्रेंट एडमिक्सचर है, ताकि उसको फिल कर सकें।
गुड, जबरदस्त, वेल डन बेटा। ओके, सो अभी कोल्ड वेदर हम किसको कहेंगे? What will be a cold weather? So cold weather can be defined as a period when the average daily temperature falls below 40 degree Fahrenheit or 4 degree C for more than 3 successive days. अगर मुसलसल 3 दिन के लिए टेम्परेचर 4 डिग्री सी से कम हो तो इस टेम्परेचर को, इस वेदर को हम कोल्ड वेदर कहेंगे। These conditions warrant special precautions when placing, finishing, covering and protecting concrete against the effects of cold weather. So when we will be doing concreting in this weather, so you will have to take special care of your concrete. Since weather conditions can change rapidly in the winter months, good concrete practices and proper planning or tactical are very, very important. So why consider cold weather when you are placing concrete in such weathers? Successful cold weather concreting requires an understanding of the various factors that affects concrete properties. Yes, you should know about the factors which can affect the concrete properties during this cold weather. Concrete in plastic state, when it is in fresh state, will freeze. We have already discussed this in detail. If its temperature falls below minus 25 degree Fahrenheit or minus 4 degree C, this may reduce its potential strength by more than 50%, and its durability will be adversely affected if you are not taking care of these factors. While you are making the concrete, you are placing the concrete, or you are handling the concrete. Low concrete temperature has a major effect on the rate of cement hydration, as some of your friends discussed, which results in slower the setting and rate of strength gain. Yes, because of this low temperature, there will be low hydration cement reaction, or low rate hydration reaction or cement hydration reaction, and this will result in the slower setting or the and the early rate gain of the early strength gain of the concrete will be very, very low. A good rule of thumb is that a drop in concrete temperature by 20 degree Fahrenheit or 10 degree C will approximately double the setting time. If there is 20 degree Fahrenheit drop in the concrete, and if your setting time is 1 hour, so it will become 2 hours. The slower rate of setting and strength gain should be accounted for when scheduling construction operations such as formwork removal. So when you need the formwork in this cold weather, if you need this so that you can use this for some other construction projects, so you may not be able to have this unless you have not used the accelerating admixtures, or if you want to work, or if you want to make multi-story structures, and if you want to continue your construction work on the after 3 or 4 or 5 or 7 or 10 days of the concreting or the work on the ground story. Concrete in contact with water and exposed to the cycles of freeze and thaw action should be air and trained. Newly placed concrete is saturated with water and should be protected from the cycles of freeze and thaw until it has attained a compressive strength of at least 3500 degrees C, or for whatever you have designed, but you have got the maximum strength so that it can resist this freeze and thaw action, and it can resist the cracking due to this freeze and thaw action. Newly placed concrete should be adequately insulated to retain its heat of hydration. You have to insulate the newly placed concrete so that you can retain its heat of hydration and thereby maintain the favorable curing temperatures. Large temperature, we will discuss, you will see this in the pictures, that how we can insulate the concrete from the surrounding temperature. Large temperature differences between the surface and the interior of the concrete mass should be prevented, as cracking may result when this temperature exceeds about 35 degrees C temperature. What is the most important thing? That the large temperature difference between the surface of the concrete and in the interior of the concrete, this difference should be not more than 35 degrees Fahrenheit, because if it is more than 35 degrees Fahrenheit, it will cause cracking of the concrete. How to place concrete in cold weather? Recommended concrete temperature at the time of placements are shown here. You can see if you the thickness of the thickness or the dimension of the section is less than 12 inches, then the temperature required is 55 degrees Fahrenheit. This is the recommended temperature. 12 to 36 degrees C is the section. 12 to 36 inches is the section thickness. Then you need 50 degree Fahrenheit temperature. And if this size increases from 36 to 72, this is just like the mass concrete, then you need lesser temperature because of the high heat hydration. So this is the 45 degree Fahrenheit which you need. So here you can see this is the age at test days 28, 7, 3, 90 days and 365 days. And here you can see the compressive strength, that is the percent of 28 days, which has been covered at 23 degrees C temperature. So here you can see if you have 4 degrees C temperature, its 365 days strength is good, but its early strength is low as compared to the 13 degrees C temperature and 23 degrees C temperature. Placing concrete in cold weather provides the opportunity for better quality. Is this one? Because if you don't have the freeze interaction, and if you have covered the freeze interaction with the help of air and mixtures, so the shrinkage of the concrete and other damages happen to the concrete due to the high temperature, that will be less. As cooler initial concrete temperature will typically result in higher ultimate strength. Here you can see this is giving the higher ultimate strength at 4 degrees C temperature. At 13 degrees C temperature, you can see S is again on the higher side. This is give you the higher maximum strength after 365 days. How to place the concrete in cold weather, as we discussed in the case of hot weather as well. The slower setting time and strength gain of concrete during cold weather typically delays finishing operations and form removal or shattering removal or formwork removal. The chemical admixtures and other modifications to the concrete mixtures can accelerate the rate of setting and the strength gain of the concrete. So you should use the accelerating admixtures wherever is possible. Accelerating chemical admixtures conforming to HTMC 494, that is type C, if you are using this accelerating, which can accelerate the hydration reactions, and type E when you are reducing the water content and also you are using this as a accelerating, are commonly used in the winter time. Accelerating the rate of set and strength gain can also be accomplished by increasing the amount of Portland cement or by using a type 3 cement, that is the high early strength cement. You can also play with the type of the cements or the quantity of the cements if you are working in cold weather concreting. Instead of using these admixtures or instead of using other methods, you can use the high early strength cements. With the help of this, you will get high early strength, and it will try to resist the freeze interaction. The relative percentage of fly ash or ground slag in the cementitious material component may be reduced in cold weather, but this may not be possible if the mixture has been specifically designed for durability. As we discussed that the fly ash or pozzolanic material, we should use the maximum quantity or the maximum possible quantity in hard weather concreting. So this is not the case in the form of cold weather concreting. You should use the lesser quantity of fly ash or no quantity of fly ash, because it will further reduce the hydration reaction. But if you have designed your concrete for durability purposes and you have added this in your design, the fly ash or some pozzolanic material, and you have covered all the other properties of the concrete with the help of accelerating mixtures or high early strength cements, then you can use it. Concrete should be placed at the lowest practical slump, as this reduces the bleeding and setting time. As one of your friends told that the bleeding of the concrete will be more and this water will remain on the surface for a long time and you will not be able to finish this concrete. So you should try to use the minimum possible water cement ratio or the minimum slump. Retarded set times will prolong the duration of bleeding. Do not start the finishing operations while the concrete continues to bleed, as this will result in a weak surface. If the concrete bleeding is in progress and you are trying to finish that surface, yes, you can do this, but it will weak the surface. It will make the surface weaker. Adequate preparations should be made prior to concrete placement. कौन से preparations are required है आपको concrete placing से पहले snow, ice and frost should be removed, and the temperature of surface and metallic embedments in contact with concrete should be above freezing. You should remove the snow, you should remove the ice, and you should remove the frost from the sides where you are placing the concrete. You should increase the temperature of the embedded materials, that is the pipes which you have used or the steel bars you have used, so that at temperature is above the freezing temperature. This might require insulating. For this you need insulation of these materials, or heating the subgrades, or either by spraying hot water on this or hot air on this, and contact surfaces prior to placement of this concrete. Development of strength of concrete is a function of not only curing time but also temperature. The strength development of the concrete is not only the function of the curing time but also its temperature. So when concrete is subjected to low temperature, heat curing is required in presence of moisture to maintain the hydration process. So to help this hydration reaction and get the maximum strength or increase the strength development, you need to use the heat curing. Insulating blankets or covering with heating arrangements to avoid the freezing and cold weather concreting. You can use some insulating blankets or covering sheets, which you will see in the pictures in the next slides. And cold water and cold weather, or in cold water weather, it is 35 degrees Fahrenheit and below. It is required to keep the freshly poured concrete and the forms within a protective enclosures are covered with approved insulation materials. So if you are working in such a temperature that the temperature is below 35 degrees Fahrenheit, so you have to cover the whole area where you are placing this concrete. Or you should use some insulating materials. The air inside the enclosures are under this insulation is required to be kept above 50 degrees Fahrenheit for at least 72 hours. आप क्या करेंगे कि जो enclosure है, जो area है, जहाँ पे आप कंक्रीटिंग कर रहे हैं, उसका टेम्परेचर 3 दिन के लिए, that is for 72 hours, it should be kept above 50 degrees Fahrenheit, so that to get the early strength of the concrete. If for any reason the temperature drops below 50 degrees Fahrenheit, अगर 50 degrees Fahrenheit से किसी वजह से टेम्परेचर फॉल करता है, ड्रॉप करता है, then what you have to do within the enclosures, within the enclosed area where you are placing the concrete, the heating period is required to be extended. And instead of 72 hours, you have to extend this to 96 hours or more. Okay, how to place the concrete in cold weather? The high strength at an early age is desirable in winter construction. To reduce the length of time, temporary protection is required. What are those temporary protections? Entrained air is particularly desirable in any concrete place during freezing weather. Temporary protection is actually you are covering the whole area with the help of this blankets, sheets, tarpaulins, and some other materials. Concrete that is not air entrained can suffer strength loss and internal as well as surface damages as a result of the present action. We have already discussed this in detail. The air entrainment provides the capacity to absorb stresses due to ice formation within the concrete. The air entrainment provides the capacity to absorb, so you should use the air entrained admixtures as required. So when you are concreting in cold weather, which type of controlling measures you should use? You can see concreting is in progress inside this enclosures, and you can see this is covered with the plastic sheets. Here you can see this has been covered with the plastic sheets. Here you can see the blankets. They are using this and they are trying to cover this with the help of this blankets. Here you can see these are insulating blankets. You can use this in the cold weather. Insulating the formwork. This whole formwork has been insulated, and you can work. You can place your concrete in cold weather. Here you can see this is the installation of the column formwork. You can see this is the concrete inside the column, and you can see this is the insulating material and this is the formwork. So you can play with this. What are the enclosures? You can use the wood enclosures. You can use the canvas, just like tarp or some other clothes. You can use tarpaulin. You can use polyethylene sheets or polyethylene films, so that you can enclose your area where you are doing the concreting. This is another advanced method, that is the indirectly fired heaters. You can supply the heat to the enclosures with the help of this. You can use the air supply, you can use the flame, you can see the clean heated air, and you can see the with the help of this ventilator or this vent, you can use this carbon dioxide and carbon monoxide and other non-desirable air content which can affect the people who are working there. That is extracted outside. So all these are the methods which you can adopt when you are working in cold weather. So Shahzad, is it okay?
Yes, sir.